Hi dears, welcome to my channel. Today we are discussing class 8, 9th lesson, that is friction. Okay, what was the 8th lesson? It was force and pressure. Do you remember? Third, we have discussed the entire class, and after that I have asked you some questions. It's a time to answer these questions. What was the first question? The first question was, which force is the contact force is the first question, and options have been given as gravity, magnetic force, frictional force, electrostatic force, like that. And the answer is what, ma? It is frictional force. Second question was, SI unit of pressure is what? SI unit of pressure is Pascal, or we can say Newton per meter square. Okay. Third question is, it was a problem. A force of 15 Newton acts uniformly over and perpendicular to the surface. When the area of surface is 5 meters square, the pressure of the area is what? So what is the formula for the pressure? Pressure is equal to force by area, isn't it? So force given as 15 Newton and area is 5 meters square. So what is the pressure automatically? 50 divided by 5. So answer is 10 Pascal. Okay, this is the answers. Now we are moving to see what, ma? The lesson number 9, that is friction. What is friction? Is there any relation with friction and force? Yes, of course. Force is the one which is needed for any moving object to stop or any stationary object to move and all, isn't it? It is the one which is required for everything to work. Consider a ball or consider something like this. Can you see? I am having a writing pad and I am having a highlighter on it. I am keeping this highlighter. What I am doing is, as I told you, force is needed for everything to move and everything to be stopped. Now I am pushing this highlighter with my hands. It came to stop. Okay, maybe a minimum force. I am pushing much more. It came to stop. Yes or no? Is there any force required for this highlighter to be stopped? Did I made my hands to stop it? No. But still it stopped. Why? Because of friction. What is this friction? Now, in detail we are learning what the friction is. Friction is a kind of force. But what this force will do is, it will oppose the relative motion between the particles. What does the friction do? The friction is a force which opposes the relative motion between two surfaces in contact. Did you get, ma? So, is there any particular direction for the friction to act? Let's check once again. Here, from right to left I am pushing and it is coming to stop. Stop, yes. From left to right I am pushing, it's again coming to stop. Is there any direction for the friction? There is no direction for the friction. The direction of friction is only against the force. The frictional force will be always against the force. In which direction the force is applied? In the opposite direction the friction will act. Did you get, ma? In what all cases the friction is acting? The friction is acting in every cases. If we are holding a pen, there also friction is acting. How? I will tell you. When we are holding a pen, actually if we are leaving this pen, the pen will come down. Means what? Gravitational force is pulling the pen down. But if we are holding the pen, the frictional force is the one which opposes the gravitational force and which enables us to write. Isn't it? If the frictional force is not there, it will be very difficult for us to write. Otherwise, the pen and the paper will glide over each other and it will be difficult for us to write. Okay? When a writing pad is there and when we are keeping a book over here, there also the gravitational pull is there and the frictional force is the one which keeps the book to be in position. When we are sliding it, to a large extent, the book is not sliding down. But if the sloping surface is more and more, the book is coming down. There also friction is acting. In every cases, friction is the one which acts in opposite direction. There in this case, the friction is acting in the opposite manner of sliding position. Okay. Now we understood a little about the friction, right? Now we should know what all things the friction depends on. Friction depends on the nature of surface in contact is the first one. If you are walking on the road, normally you are able to walk. Or if you are running on the road also, it's quite common for you to run. Okay. But if you are standing on a peel of banana, what happens while you are running? You will fall down, right? Isn't it? You will fall down. So how is it doing? How is it working? This is because frictional force over there is getting less. When the friction is getting less, the sliding over will be more. Did you get, ma'am? Okay, that's why on the smooth surfaces, or to say when it is the rainy time and the road will be fully muddy sometimes. Wetty mud is there. If you are running on that same road, it will be chances for you to fall down. Because wetty mud makes the floor more and more smooth. If the surface is more and more smooth, friction will be very less. Okay, so friction is depending on the surface. If the roughness is increasing, what happens? The friction also get increased. If the smoothness is increasing, the friction also will get decreased to the minimum. Okay. Second is friction depends on the normal force with which two surfaces are pressed. That also can be explained very easily. If in your house a mat is laid down, if your mother is saying, please take the mat, like that, if someone is saying, you can take it so quickly. Yes or no? Okay. If in the second case, if your sister is sitting on the same mat, okay, if your sister is sitting on the same mat, if you are trying to take the mat, can you remove it quickly? No, because of the weight of the sister, you will say, isn't it? So it's not because of the weight. As the object is getting heavy, the friction also will be much more increased. Okay, that's what it is said. The normal force with which two surfaces are pressed. When the surfaces in contact are much more heavy or heavily pressed, what happens? The friction will be increasing. Did you get, ma'am? Okay, these are the two things the friction depends on. Okay, then I told you the friction is caused only when the surface is rough. Why? When the surface is rough, why this friction is acting more? Because when the surfaces are rough, irregularities are seen in the surfaces. Irregularities. What do you mean by this irregularities? If this is the surface, much more irregularities can be seen. If the irregularities are the seen, if any other surface is in touch with that, the other surface will be blocked, or the second surface will be pressed with the first surface. So what happens? The friction will be more. So we have to apply much more force for moving it. Okay. So the irregularities are the reason for the friction. If the irregularity is more, friction also will be more. If the irregularity is less, friction also will be less. Friction is caused due to the irregularities of the surfaces. As I told you, friction is a contact force, isn't it, ma'am? Friction is a contact force. So it came into applying only when two objects are in contact with each other. So what happens? As I told you, the surfaces will be always irregular. Okay, so when irregularities are more, the two surfaces which irregularities will be pressed together. So when we are trying to move it, it will be very difficult to move. Okay, so we can say the friction is more. Thus, the static friction. What is the static friction? Static friction is the one which is applied only when two surfaces in contact are stationary. Okay, when two surfaces in contact are not moving or it is stationary, we can say it is the static friction. When when a car is moving and suddenly come to stop, what your father will say? Come out and push the car. from backside. Have you had an experience, bad experience like that? Okay, if you are having a bad experience, you will understand how difficult it is. It will be very difficult to push the car from backside. Because actually when the car is stopping, the tire and the road are pressed together because of the irregularities. Okay, so when we are trying to move the car, we are applying force. But as we are applying force, this friction also get increased. Okay, to a large extent, as the force is increased, friction also get increased, and when it reaches a particular point, the friction will be reduced and it starts moving. This is the graph. Okay, about it you will learn in the 9th standard in detail, but still I am saying when it is reaches to a maximum, we are saying it as limiting friction. Okay, static friction it is, and it is reaching the maximum limiting friction, then it starts to move. Okay, now what I am saying is when the car is trying to move, much more force has to be applied for the car to be in motion. But when the car started to move, the force is not that much required than the initial one. Okay, ma? So we can say the static friction is higher than sliding friction. What is the sliding friction? When the object is sliding over the another, the surface in contacts are not interlocked again, isn't it? The two surfaces, when two surfaces in contact are stationary, they will be interlocked and it will be very difficult to move it. But when one surface is gliding over the other, the time for interlocking the surfaces is very less. So it is called sliding friction, and it is much less, so lesser than that of the static friction. Understood, ma? And the third one is rolling friction. What is rolling friction? Rolling friction is the one which is much less than static or sliding, because when the wheel is fixed on the objects to move, is it easy or difficult for moving the objects? It's very easy, because friction will be very less over there. So we can say in general, static friction is greater than sliding friction is greater than rolling friction. Okay? Understood? Static friction is greater than sliding friction. It's greater than rolling friction. Okay. Now we understood about the types of friction, right? Now we have to ask whether the friction is good or bad for us. Is the friction good for us or bad for us? An important question is arising. Is the friction a friend for you or an enemy for you? Both, isn't it? Both is the answer. Friction as a friend. Now we are seeing how the friction is helping us. Okay. Friction helps us to walk. Friction helps us to hold our pen. Friction helps us to write. Friction helps to apply brake on the vehicles. Okay. Then we can say it helps to tie knot. It helps to move. It helps to fix nail. It helps to screw. All these things are possible only because of friction. Okay. This frictional force is very important for our lives. If there is no friction, imagine a case when friction is not there. If a ball is starting to move, it will not stop. It will be go on moving. Okay. And if the friction is not there, we are not able to walk even. If the friction is there only, all these things are happening. So friction is needed or not? Friction is absolutely needed for us. Okay. So where the friction is acting as an enemy? When we are using slippers or shoes for a longer time, the soles of the shoes will be damaged. Have you seen? For 1 year when you are using the same shoes, the soles may have damage. Why? This is because of the friction of the shoes sole with the ground. All the time friction is acting. That's why there will be a big hole over there, isn't it? Or sometimes the shoe's front part also may be damaged. All All this is because of this friction. Okay. This friction causes wear and tear for the machinery parts also. Machine parts, when they are running for a longer time, what happens? The parts will be damaged. Okay. Then we can say, have you seen your mother using the mixer grinder? When she is using the mixie, after some time, if she is using it vigorously, when she is stopping, just go and touch the mixie jar. It will be hot. Have you seen? Unnecessary, some force is lost over there. Because of this friction only, the unnecessary heat is generated. Why should we go for the mixie? We can go within ourselves. We can come within ourselves. When you are rubbing your palm for a longer time, heat is generated. Yes or no? This is because of friction only. The two palms are in contact with each other. Because of these irregularities, friction will be generated. Then also we are applying force. Then also friction will be more. At the end, because of this friction, heat is generated, and when you are keeping in your cheek, what will happen? We can feel the heat. Because of the friction only, the matchbox is lighting. Okay. The matchbox is lighting because of the friction only. There, not only heat, the sparks of light also will be coming. Yes or no? So this friction causes wear and tear. Unnecessary heat can be generated, or unnecessary light glow will be formed. All these, by this way also, the energy will be lost, right? Energy will be lost. So to a little extent, the friction is enemy for us, isn't it? So for us, for every negative, we will try to make it positive, isn't it? We are trying to make every negative as positive. So we can reduce the friction. How we can reduce the friction? One way, what is that? As we know that static friction is greater than sliding friction, which is again greater than rolling friction. So when we are fixing wheels over the luggages, it will be easy for us to take, isn't it? That's why in our suitcase nowadays, wheels are fixed. Rolling friction is much more less. The force which we have to apply is less needed for the rolling things. Okay, that's why. Now, the same wheel is applied in machineries. If two parts are rubbing each other in the machinery, two parts have to be rubbed each other. We will be placing the balls in between. So, along with these two parts, the ball also will be rolling. We will say it as ball bearings. In our cycles also, ball bearings can be seen. For making it easy for moving, the friction will be reduced. The cycle can be rolled easily. These ball bearings are used over there. Then, as I told you, due to the wear and tear, the machine parts are getting damaged. This wearing and tearing can be reduced by applying lubricants, by applying some oils or greases. We are saying it as lubricants. When we are applying these lubricants, the lubricant will be in between these two surfaces. So the frictional force can be reduced. Okay. By this way also we can reduce friction. Okay. Now, this frictional force, in many cases the friction is very friend for you, isn't it? So in what all cases friction is acting as friend, we will say. That is, when the heavy loaded vehicles are traveling, their wheels have to be threaded. Have you seen the threaded wheels? Threaded wheels are there for the vehicles. So when the threaded wheels are there, it will increase the friction. So this wheeled vehicle can climb even the top of the mountain. Okay, the slippery will not be that much felt. This friction will be much more increased over there. So the vehicles can travel a long distance, and it can travel in marshy areas or hilly regions and all. Okay. Then for the players, their soles, have you seen spikes on the soles? For the players to play, the spikes will be fixed on their soles. For what reason? To increase the friction, so that they will not fall down. Even though they are doing some vigorous move and all, they will not fall down because of this spikes on the soles. Have you seen the kabaddi players playing? The kabaddi players, while they are playing, they will take the sand and press in their hands. Why? For increasing the grip over themselves. Grip can be increased or friction can be increased. Then for that purpose, the sand has been just spreaded on their hands. Okay. So from this we can understand only one thing, that is friction will be more when irregularities are more. Friction will be less if the irregularities are less. That is, for the smooth surface friction is very less and for the rough surface friction is very more. Now I am asking you a question. While we are playing caroms, powder is put. Yes or no? Then when you are playing the caroms, what you are doing? You will spread powder. Will it increase the friction or will it decrease the friction? It will definitely decrease the friction, so that the caroms can move slightly, smoothly. Isn't it? Okay. I think you have understood the chapter. One more topic we have to discuss. That is fluid friction. What is fluid friction? Friction is applicable in fluid also. In water also friction is there. Friction will act as a drag. Consider a swimming pool. Two children are there, A and B. Let A to walk in the swimming pool. Let B to walk in the floor of the swimming pool. Who will walk faster? Two children kanna. A is walking in the swimming pool because the water will be up to this extent only. He have to walk quickly. And B has to walk in the floor of the swimming pool. Who will walk faster kanna? B will walk faster. Why? Because the water is resisting the A to walk forward. That is called dragging. Fluid friction is applicable in water much more than fluid friction which is applicable in air. In air, the fluid friction is there, but it is less compared to that of water. Okay. That's why those who are flying in air or those who are moving in water will be having streamlined body. Have you seen? Streamlined body. The fishes will be having streamlined body so that they can move, they can reduce the friction while it is traveling in water. And the birds also will be having what? Streamlined body, which enables them to move through the air freely. That's why the ships is having the same streamlined body as that of the fish to move easily in water, and the planes having same streamlined body like our birds for moving easily in the air. In that cases and all, the friction will be much more reduced. Okay. Now I think you understood the chapter very neatly. Now I am not going to leave you. It's a question time. First question. Sprinkling of powder on carom board dash friction. I think in the class I have asked you and it's very easy for you to answer. Sprinkling of the powder on the carom board dash friction. Will it increase the friction or will it reduce the friction is the question. Okay. Second one. Friction is dash on rough surface. Friction is dash on rough surface. Is it large or is it small? Okay. Third one. Is it possible to eliminate friction entirely? Is it possible to eliminate friction entirely? Frictionless world will be there is the question. Think and answer, and we can meet in the next class. Bye.